Hello, welcome to the LinkedIn Live session with Altera. I'm your host, Rubina Maharjan, and I'm delighted to have you all here. For today's panel discussion, we are joined by Peter Brooks from Altera, Sean Luke from DigiKey, Liz Chen from Terasic. Thank you all for joining me, and to our audience tuning in, please feel free to drop your question in the chat. We'll be sure to address them along the way. So today we will be exploring how FPGAs are shaping the future of video vision applications. Before we dive into the panel discussion, let's take a look at DigiKey's unboxing video of Altera's Agilex 3 FPGA C-Series development kit.
It's time for a DigiKey unboxing. Let's take a look at the Agilex 3 FPGA C-Series development kit from Altera. Agilex 3 FPGAs offer higher integration, enhanced security, upgraded performance, and lower power consumption for industrial, surveillance, retail, consumer, video, and medical applications. So let's get started. Inside the box, you'll find the Agilex 3 FPGA C-Series development kit, a USB-A to USB-C cable, and printed documentation. The kit supports expansion using the Raspberry Pi Hat or PMOD connectors. In this demo, we're going to run Altera's Board Test System, or BTS. You'll need to install the Quartus Prime software to support the demo and have it opened to set environment variables, but you don't need to keep it open to run the BTS demos. Connect your computer to the USB-C port on the top edge of the board and connect a 65-watt USB-C power source to the USB-C port on the left edge. We're going to run a DisplayPort loopback test, so we also need a DisplayPort cable plugged into both DisplayPort ports. Then turn on the power switch. Open the BTS GUI and click the Agilex 3 button. This displays the board info. Click the Configure menu and you'll see the different test designs. Select the DisplayPort transceiver loopback design. Once it loads, you can select different data types and change PMA settings, and then start the test. Then you'll see the data rate and bits transferred, and you can insert errors, which will then give you a bit error rate. You can also check the PLL lock and pattern sync status. You can reconfigure the board with the other demos, and Altera provides an example project to use as a starting point. Thanks for watching.
Well, thank you for watching, and that was a pretty cool video, I must say. So let's get started with our panel discussion here. Peter, to start us off, what exactly is video vision, and what makes Agilex 3 device right platform for video and vision application?
Thanks, Rubina. That's a great place to start. Video and vision, what is it? You can think of video as the data, the streams of pixels that are coming from sources or sensors and distributed and processed and routed through the system. And you can think of vision as the intelligence, the manipulating and enhancing the data and extracting insights and meaning from that data. So it might be detection or classification, and then subsequently guiding automation or providing an enhanced view to the user. So video and vision technologies are everywhere. They're in all kinds of applications, and consumption's continuing to grow very rapidly from the cloud compute right the way through to the embedded edge applications, whether it be smart cameras or robotics, Pro AV equipment, medical imaging, autonomous systems, drones, so on and so forth. And it's this embedded space that's a real sweet spot for Agilex 3. And that's particularly true when you're looking to enhance and maximize performance within a cost-sensitive and low-power application. And let me give you a quick example of that with regard to performance and to scale as well. So with Agilex 3, it will integrate software and hardware, and the programmable logic, which is a second-gen HyperFlex architecture, It allows designers to develop HD and 4K vision and video systems very efficiently, often with 1 pixel per clock. And it can maximize that operating frequency. So it's really well suited to low latency applications, and also applications where you need really precise control over the application and the data, even at the clock cycle level. So you can build out your product, you can add features, remove features, and deploy variants of that product across a portfolio for your customer portfolio. And then you can actually do that within a device, or you can do it within the device family of Agilex 3, or you can actually migrate up to Agilex 5 as well. So say you're working on a 4K solution and you want to enhance that to 8K, you can move into the Agilex 5 domain, but maintain and still use the same IP and use the same toolchain.
Thanks, Peter. Definitely, I love the way you put it, video being data and vision being intelligent. And of course, video is everywhere as a data we are consuming every day. And as you all are watching this video, this is the video data you all are consuming. So there's a enormous rise in the video data consumption, and we are excited to have Agilex as a device and the platform to accelerate the video vision application. My next question is to Sean. Sean, from your perspective in the engineering community, what demand or design trends are you seeing around Agilex 3?
Great question, Rubina. Really appreciate being here. Thanks for this opportunity. DigiKey is super excited to be part of this, and we're really grateful for all the pieces that you pulled together here. Great setup from Peter talking about video and vision, because as we think about the engineering community and those trends that are going on, we're seeing more and more high bandwidth, high capture data going on at that edge. And as Peter had said, is low to medium density FPGAs and this cost-effective pricing, like it's becoming a big piece of things like transportation. Transportation is not only the things that we see on the road, but it's also the autonomous vehicles that we see in factories. They need the safety features. They need these full capture machine vision cameras going in. It's loads of data. Autonomous navigation is something we're definitely seeing more and more of. And then also we see high capture rates within manufacturing and distribution, whether that's for quality control, defect management, predictive maintenance on factory equipment, and all the way down to healthcare as well. So there's a series of different verticals that are really driving the demands for this, whether it's analyzing medical images, being there for surgical assistance. There's just a whole array of video and vision applications out there. Thank you.
Well, that's definitely a diverse set of application that you shared, Sean. Thank you for that. Moving on to my next question is for Liz. So Terasic develops a broad range of Altera-based hardware solution, and many focused on video and vision processing. In your markets, what are some of the key challenges and emerging use cases for next generation system?
Thank you, Rubina. It's really a pleasure to join this discussion today. At Terasic, we work with our customers building complex edge vision systems. And one of their biggest challenges is integrating AI, sensor fusion, and even real-time control into a single low power and complex platform. These systems, they aren't just about basic video capture. Many customers, they are dealing with multi-modal sensor inputs and tight timing constraints, and the need for custom hardware pipelines. So they are asking us to support not only image preprocessing, but also lightweight inference and I/O control, all in a deployable edge device. And we've seen this reflected in several real-world applications, and I'll share some of them today. So the first project is the solar-powered smart cameras, where our customers, they uses the Atom A3 Nano based on Agilex 3 to run the basic CNN inference and pixel preprocessing under the strict power limits. It's really ideal for remote or off-grid installations. And the second project that we've seen our customer doing is the compact robotic arms, where they use our D23 Lite, also based on the Agilex 3. That board is used for prototyping the HDMI-based vision pipelines with real-time motor control. And the customer, they can later transition to the Atom A3 Nano once our upcoming MIPI version is ready for production. And then the third project is the atomic clock control systems, where both the Atom A3 Nano and our Agilex 5 SOM, they are used depending on the precision required, like from mobile timing nodes to high-end synchronization. Yeah, and another very interesting project is the multi-sensor video telemetry systems, where our platform fuses data from thermal and even GPS sources in real time. Our Atom A3 Nano is really ideal for edge side processing. So across all of these, really, our role is really to make the FPGA adoption easier by providing vision-focused hardware and ready-to-use IP and reference designs that let the customer focus on their application logic rather than the low-level integration. Whether it's prototyping on our D23 Lite or scaling with the Atom A3 Nano, or even onto our Agilex 5 platforms such as the D25 Nano and Common X65 SOM, our goal is really to support the full path from development to deployment. Thank you, Rubina.
Well, those are very interesting use cases, Liz, and we truly appreciate a Terasic partnership on this, driving and helping the adoption of FPGA easy for our developers. Moving on to Peter, going back to Agilex 3 here. So looking at Agilex 3, Peter, how does it compare to previous generations of FPGA when tackling vision tasks like low latency streaming or AI inference?
Yeah, so Agilex 3 is faster, more integrated, and more efficient than the previous generation Cyclone branded FPGAs. And if you go beyond performance, you get up to 1.9x increase in operating frequency, but there's also a number of other enhancements and improvements that are very relevant to vision and AI-based systems. And I'll run through a few of them for you. Let's start with I/O, getting the vision data on and off the device. Agilex 3 integrates in MIPI DeFi, so you can very efficiently interface to sensors, camera sensors, and displays. It also provides 12.5 gig transceivers, so you can support PCIe Gen 3, and also video protocols including SDI, HDMI, and DisplayPort. On the memory side, there's support for LPDDR4, so you can very efficiently buffer HD and 4K video frames, as well as weights for AI inference model. And then on the networking side, supports 10 gig Ethernet, so you can build out your video over IP system or RDMA over Ethernet to integrate with other compute clusters as well. So you have this multitude of I/O capability, but that's the first point. Then you move into compute. Within the fabric, within the programmable fabric, you have configurable DSP blocks distributed, and they've been enhanced to include a tensor mode. So this is a very dense compute. You can perform up to 20 operations per cycle, and it's very well suited to AI inference model development. The DSP blocks also support floating point, so you can explore that space of fixed point, floating point for your applications, perhaps an optical flow algorithm or some HDR implementation you might be looking at. So that's the second point. The third point is security. Agilex 3 provides a secure device manager, so you can protect the configuration of the FPGA and also manage a long list of various security features, including post-quantum cryptography. And last, but absolutely not least, very important, it's enhanced processor capability. So in soft logic, there's a NEOS 5, which is a soft processor, a 32-bit RISC-V ISA. And there's also a hardened dual-core ARM Cortex-A55 plus peripheral subsystem that allows you to run Linux or your favorite RTOS alongside the FPGA. So you can run your software stack, perhaps your containerized application. You could coordinate vision tasks from software, and even run lightweight inference in that environment. So faster, more integrated, and more efficient.
Thank you. So faster, more integrated, and more efficient. Definitely something to look forward for our developers. So switching gear a bit here now, we talked about the use cases and we talked about how Agilex 3 can enable those use cases. I would like to now focus on how our partners like, DigiKey and Terasic is enabling the developers who are developing FPGA devices. So my next question is, Sean, to you. DigiKey is known for enabling quick prototyping. So what resources do you offer for developers building video vision application on Agilex 3? And my follow-up question is, can you share how DigiKey and Altera are working together to reduce the learning curve for new developers who are exploring FPGA-based vision?
Thanks, Rubina. Yeah, a great set of two questions there. First about the prototyping, how we enable the prototyping specifically for Agilex 3, and then the second part being FPGA based vision in general. So yeah, on the first part, we are very involved and we're proud to say that we've got an inventory of Agilex 3 devices, including the development kits. And as Liz was talking about earlier, Terasic's Atom A3 Nano board based on Agilex 3. This is a great way to speed up those development cycles, having all the pieces on board and ready to go. Really excited and grateful that we have this partnership here and that we're ready to get these into the hands of FPGA developers. We have a series of different design resources, including webinars, tech forums, articles, and reference designs to help with this. Altera likewise has learn.altera.com. And in general, we just want to increase the proliferation of FPGA designers. This is a great discussion because everyone is underlying the use cases, why this is so relevant at this time, how video and vision is pushing us forward. In general, the DE10 Nano is also a great getting started board from Terasic with an Altera chip on it. And we also have a partner called Labsland. It's been a great way to provide remote hardware. And what this means is that students or developers, those that maybe aren't fully sure about getting involved in the FPGA environment, they can go in and remotely use these FPGAs for free. They don't have to download the SDKs. They can still input their Verilog and VHDL, and they can try the hardware before they buy it. So yeah, really grateful to be here, and we want to create that opportunity and continue to proliferate FPGA designers.
Thank you, Sean. I'm going to move to Liz. Liz, I wanted you to share a little bit on, how Terasic is enabling customers with Agilex 3 devices and what kind of development resources are available for video vision applications.
Sure, that's a really great question, Rubina. So at Terasic, one of our key goals is to help engineers prototype and deploy video vision systems faster, especially on new FPGA platforms like Agilex 3. So for Agilex 3, we've launched two development kits. The first is the Atom A3 Nano, and the second one is the D23 Lite development kit. And both of the kits, they are optimized for edge vision use cases. These two boards, they are very compact and also cost efficient and come with rich IOs like the HDMI, TMD headers, and GPIO for real-world sensor integration. Both our Atom A3 Nano and D23 Lite, they're shipping now and available through Terasic and also our amazing distribution partner, DigiKey. These boards, they are designed specifically to help engineers ramp quickly into video and vision workloads with a very compact and low-power Agilex 3 platform. And then we will even have a MIPI enhanced version in next Q2 for both platforms. And in terms of the resource, we provide first the reference designs for video pipelines, image capture, and also preprocessing on FPGA fabric. And the second one is we provide documentation and tutorials that walk new users from board bring up to complete vision demos. And the third one is expansion options. So for example, camera interfaces, HDMI, and high-speed I/O that let the customers prototype real use cases directly on the hardware. And we're also actively expanding our resource. More developer collateral and GitHub projects and design examples will continue to roll out. So make sure you are subscribed to updates from Terasic and Altera. Right now, you can start today with our Automate 3 Nano or D23 Lite, and you'll have an increasing stream of reference designs, documentations, and community support as Azure 3 adoption grows.
Well, that's a whole lot of resources that Liz and Sean share. So thank you. And I believe there's more that you could learn and get access to. So please do visit the websites that both Liz and Sean referred to. At the same time, tools are really critical for driving the FPGA adoption. So my next question is to Peter. Peter, how is Quartus Prime helping accelerate vision development on FPGAs?
Yes, you're right, tools are absolutely critical. It's all about improving developer efficiency for the development of FPGA and SoC systems. We see a need for not just the Quartus Prime tools, though. We have tools for FPGA developers. We have tools that allow very rapid iteration cycles, especially on Agilex 3 and the fast compile times. We have tools for embedded SoC designers, and we have tools for DSP designers as well. So you can build out, there's a block set called DSP Builder Advanced block set that integrates into the Simulink MathWorks tools. So you can work at an algorithmic level, and then you can generate IP and RTL that integrates into platform design and the system level tools in Quartus Prime and integrate into the design very smoothly. We have tools for AI developers as well that integrate into those standard frameworks for AI model development. So we have a multitude of tools there, but specifically for vision, the IP is a real game changer. And I'll quickly explain why. There's a multitude of IPs. There's over 50 IPs available, which are highly parameterizable and modular. I mentioned the I/O before, but also the algorithmic IP, warping, transformation IPs, format conversions, ISP, image signal processing, time synchronization, switching, routing, etc., and so on and so forth, and integration with AI IP as well. So it's more than IP, and this is a really important point. It's about a plug and play integration flow. And with boards like you've heard about from Liz and from Sean, you have a platform where you can build with the IP many system configurations without writing RTL. So it's not an RTL, there's flow. And then with integration with the software, you've got a very fast iteration cycle. So really important. We've got board awareness features coming out, modular design toolkits available through the Altera developer site, alongside many drivers and software starting points as well. And upcoming very, very soon, we've got the upcoming Altera Innovators Day, and there'll be a number of announcements there, amongst other things on new software products and tool enhancements. So that's really about improving that developer efficiency.
Well, that's great. Definitely, we have our upcoming Innovators Day event soon on September 38th. If you have not registered yet, please do register. This is a hands-on event for our developer audience. We are hosting at our San Jose campus, so we're looking forward to seeing you all at the event. So this is my last question. I'm going to be asking to Liz, and then of course, Peter and Sean, feel free to add your perspective as well. My last question is focused around edge computing. So finally, the shift towards edge computing is reshaping system design. How is this trend changing the way engineers build video vision systems today?
We're definitely seeing a shift. Engineers, they want to process the entire vision pipeline at the edge, from camera input all the way to decision input. Instead of just streaming videos, they need compact and very power-efficient hardware that can handle real-time pixel operations, multi-sensor sync, and tight control loops, things that CPUs and GPUs alone can't always do efficiently. So that's where our FPGA-based platform come in. So for example, our D23 Lite and D25 Nano that engineers prototype MIPI and HDMI pipelines with control signals. And our Autumn A3 Nano is also very great for low-power smart cameras that need pixel preprocessing plus like neural inference. And we also have Agilex 5 platforms that support high bandwidth sensor fusion and deterministic control for autonomous platforms. And on top of that, we provide reference designs with camera input, buffering AI integration, and I/O control. So customers, they can skip the low-level bring up and focus directly on their application. And at the end of the day, it's about giving engineers the tools to run vision and AI right at the edge. Just plug in the camera and load the logic and go.
Peter?
Yeah, absolutely. There's a tremendous number of influences on that move to the edge, whether they be business, economic, regulatory, even, and customer desire and demand. But in that space, it's what we're seeing on the system design side is really an interesting requirement for flexibility. It's a flexibility to explore architectures as well as algorithms in that space, both in software and hardware. And Liz mentioned a couple of times about a sensor fusion problem. So let's look at that as a quick example. If you have multiple sensors coming in, you can make a decision to extract features very close to the sensor, and you perhaps make a fast decision. Or you might want to perform some pre-processing on that data and clean the data, so perhaps enhance the accuracy of the actual extraction and the analysis done at the end of that pipeline. Or maybe you want to take all of the data, put it into a common coordinate system, fuse the data, and then perform an extraction. There's many different ways, and you're making trade-offs between latency, decision time, and accuracy as well. And it's different for every different application. So that flexibility is where we're seeing this excitement and traction around the Agilex 3, 5, etc. Product families. It's a super exciting time. So customers can ultimately differentiate now with their products and get something shipped, knowing that they can also make changes in the future.
Sean?
Absolutely. Very humbled to be here and to have this discussion. Everything that Peter and Liz are saying, it gets me so excited because these are primary challenges that people are up against. I really resonate with the words that they're using, the way that they're laying this out here. I'll just try to provide my own little spin on this as well. Like, yeah, there's all this real-time data, this high bandwidth image processing, along with the sensor processing that's going on. We're trying to reduce the bandwidth to the external systems by doing as much of that at the edge as possible. With that, there's always these concerns around data privacy, in particular when you're working with vision and video. We don't want to be sending things to multiple hops and pushing it all the way out to the cloud, where then we have to do more audits and make sure that the data is scrubbed and kept private and everything. So I think this discussion, it's at a great time, and the hardware that's being provided here and the solutions that are being provided are wonderful things. So thank you for this opportunity. I was glad to be part of this discussion. Thank you.
Well, thank you, Peter, Sean, and Liz, for your insights. And thanks to our audience for joining us today. We will close with the demo from Alexei, showing how the Agilex 3 FPGA dev kit takes video vision from camera input to 4K output in a minute. So until next time.
Hey guys, I'm Alexei Lopic, and today we will have a quick hands-on look at Agilex 3 FPGA development kit. At a high level, Agilex 3 brings many high-performance features in a cost-optimized package. These features include high-speed transceivers, an EMIF, HyperFlex architecture, and AI-infused DSPs for complex processing demands. At a system level, it also has a dual Cortex A55 ARM cores, LPDDR4 support, and many security features. All of that comes at a low logic density and in a tiny variable pitch BGA packaging for easier signal routing. To double click on this and many more features, please check the Altera website. But today, I'd like to have a look at real hardware. Here I have 3 Agilex 3 development boards. The first one is from Altera and is called Agilex 3 FPGA C-Series Development Kit, and I will base my demonstration on it. The other 2 kits come from Terasic and are called DE23 Lite and Atom A3 Nano. These are also elegant, powerful and compact platform with many connectivity features, so the design I show today can be ported to these boards as well. Let's get back to the Altera C series dev kit. There are many Agilex 3 features that this kit exposes, but in today's demonstration we will use the following: MIPI D-PHY 2.5 interface for sensor connection, LPDDR4 for video frame buffering, DisplayPort 1.4 for 4K video output, and onboard USB Blaster 3 for programming. Because I want to demonstrate a camera design, we do need an image sensor and a lens. For this, I am using a Raspberry Pi high-quality camera module. To connect this module to the dev kit, I will use an adapter camera cable. The connector can be a little bit fiddly, so do take your time. And the rest is very straightforward. Connect DisplayPort output to a monitor, connect USB Blaster to a laptop, and finally, connect USB 3 Type-C connector to a capable power supply. And that's it. Now, let's fire up the Quartus programmer and then power up the board. You can identify the hardware in this menu. Once the hardware is identified, you can perform auto discovery to identify all devices in the chain. In this instance, I'm only using soft file, so I will load it by right-clicking on the device and selecting the corresponding file. Finally, I'll program the device by clicking Start. Let's give it a few seconds. And as you can see, the link between the image sensor and the video output is now live. What I have running is a simple camera solution with the following key components: MIPI CSI2 protocol IP core to interface with the sensor, DisplayPort 1.4 IP for video output, various IPs from video and vision processing suites such as black level and white balance correction, video frame buffer and demosaic to implement a basic ISP pipeline, and finally NIAS5 soft processor for the overall pipeline control. Some of the controls are exposed to the user via the JTAG terminal, so you can modify overall exposure, adjust color temperature, and turn the features on and off. Hopefully, with this quick demonstration, I did show you that you can get camera and video designs going on Agilex 3 very quickly. And with its broad range of connectivity and processing options, Agilex 3 provides an ideal platform to develop such solutions across the broad range of applications. To learn more about the technology, visit the Altera website, get your Agilex 3 dev kit and start developing today. Happy designing!